Welcome. What I'm going to do in this video is explain how to approach a FMAVoVDAT problem. FMAVoVDAT is nothing more than the combination of Newton's second law, or the FEMA part, with the kinematic equations, or the VoVDAT part. FMAVoVDAT. Before we begin, I want to make sure that you understand clearly what all the letters of FMAVoVDAT represents. When I say FMAVoVDAT, it's just a way to organize your variables to solve a problem that will require you to use more than one equation. So let's look at the chart. FEMA, that's Newton's second law. Force, mass, acceleration. And here are their corresponding units on the right. Force, mass, acceleration. VoVDAT, these are the five kinematic equation variables: initial velocity, velocity, displacement, acceleration, time. By arranging your variables like this and using the units to recognize them, it's going to help you fill in the charts and pick the appropriate equations to solve a problem. So every FMAVoVDAT problem, we're going to have this chart, FMAVoVDAT. And you're going to have to, first, identify your variables. You will do that by recognizing the units from the chart on the previous page. Now, I want to point something out. In FMAVoVDAT, the variable A for acceleration appears twice. Acceleration is the linking variable that you can use to bridge one equation to the other. So, depending on the variables that you have, we know that Newton's second law is F equals ma. Force equals mass times acceleration. We know this can be rearranged to form mass equals force divided by acceleration, or it could be rearranged to form acceleration equals force divided by mass. So it is possible that if a problem gave you a force in newtons and a mass in kilograms, that you could solve for the acceleration. And that acceleration could then get applied down to the bottom set of equations. Now, what are the kinematic equations that we are going to use for the five variables on the bottom? Well, V equals V naught plus AT. D equals V naught T plus 1/2 AT squared. And V squared equals V naught squared plus 2AD. Here are the three kinematic equations that we've used before, and we're now going to use again. These kinematic equations are exactly the same as the ones that we saw earlier in the year. Pay attention to where the signs are. Where's the plus sign? Where's the square? Where's the half? And remember, you have to do all of the functions in the equation. So, if there's a FMAVoVDAT problem, what do? First, identify your variables. You fill in the FMAVoVDAT chart. The second step always is going to be to solve for the acceleration. How? Well, if you have a force and a mass, you can solve the acceleration using Newton's second law. But if you have three of the four variables in the kinematic equations down here on the bottom, you can solve for the acceleration with one of those. There's not going to be a set way of doing it. You have to be able to problem solve, fill in the chart, and understand what variables you have. But once you solve for the acceleration, the acceleration transcends the equations. The acceleration you have in the kinematic equations is the same acceleration you have in Newton's second law, or FMA. Once you have the acceleration, it will become easier to solve the desired quantities. So let's do some examples. I am going to read the question, and I am going to annotate it as such. What force? We're looking for a force. Okay, we're looking for a force. Did a 30 kg, okay, 38 kg. 38 kg is a mass, and if you forgot your units, go reference the chart that was shown earlier in the video. What force does a 38 kilogram biker move with who accelerated from rest for 6 seconds, okay, times 6 seconds, that's pretty simple, and ended up moving 15 meters per second? Well, if you end up moving 15 meters per second, that's a final velocity. How did you know that was a final velocity? Because it said ended up. And there's another thing that I wanted you to recognize here. I wanted you to recognize the term from rest. We have to remember that sometimes variables can be given as words in a problem. From rest to a stop. And from rest means something very specific. From rest means that the initial velocity, or the v0, is 0. All right, so we're looking for the force. We have the mass, the v0, the v, and the t. Okay, I'm going to draw the line right here just to separate my variables. In order to solve for the force, I need a mass and acceleration, and I don't have an acceleration. So I am going to need to use one of the kinematic equations to solve for the acceleration. So I know I need to have an equation that has an acceleration. Acceleration equals question mark. I have a v0, I have a v, and I have a t. These are my variables. There is only one kinematic equation that has these 4 variables. V equals v0 plus at. Oh, okay. 15 equals 0 plus a times 6. I'm just plugging the variables into the equation. 0 plus anything is itself. 15 equals 6a. Divide. Okay. So the acceleration is 2.5 meters per second squared. And if I know that the acceleration is 2.5 meters per second squared down here, that means the acceleration is 2.5 meters per second squared up here. Remember, acceleration transcends the equations. So now I could just use F equals ma, because now I have the mass and I have the acceleration. And what I get by plugging that in is 95 newtons. That's it. The force is 95 newtons. If you didn't remember that was newtons, go reference the chart earlier in the video. And I know what you're asking. Bazzuto, why didn't we use the distance, the displacement, the d? Why did we not use this variable right here? Well, every time, there's going to be one of these 5 variables that just simply does not enter use. We didn't know it, and we didn't need to know it. So we can ignore it. Every time, there'll be one variable in the chart that you can ignore. Now let's go ahead and look at a different one, okay? Let's read this question. How fast did a 12 kg, I'll just mark this up. did a 12 kilogram condor end up flying? So I'm looking for the final velocity. When I see end up, that indicates to me a final. If it was moving, that indicates an initial 21 meters per second. Remember, meters per second is the unit for both velocities over a distance of 115 meters. All right. With a force of 20 newtons. Okay. So I am looking for the final velocity. I absolutely need an acceleration. This time, I actually have the force of the mass. So I could just use the acceleration equals force over mass equation to get it. It might even be a little bit easier here. 20 divided by 12 is a 1.6 repeating, so I'll just call that 1.67. So I know that the acceleration down here is 1.67 meters per second squared. So I don't have any mark next to t. So for this question, t is going to be the variable that we ignore. But wait, you don't have any mark next to v. Oh, I have a question mark because that's indicating that I'm solving for it. So I have to pick the one kinematic equation that has a v0, a v, a d, and an a. And of course, the answer to that is everyone's favorite, v squared equals v0 squared plus 2ad. I'm just going to plug my numbers into it. V squared is what I'm looking for. V0 is 21 squared plus 2, 1.67, 115. All I'm doing is plugging the numbers in from my FMAVoVDAT chart into this equation. I can type all this in a calculator, but just in case you wanted to know, 21 squared is 441, and 2 times 1.67 times 115 is 384.1 equals v squared. So when I add these two numbers together, I get v squared is 825.1. But I don't want v squared. I want v. So I actually have to square root both sides. So when I square root both sides, I'm going to get v equals 28.72 meters per second. So I can say that the final velocity in this question is 28.72 meters per second. FMAVoVDAT. This last question is going to deal with negatives. And I just want you to know that negatives matter. Force can be negative, acceleration can be negative, velocity can be negative, displacement can be negative. Just time and mass are the only ones that cannot be negative. There's no such thing as a negative mass. There's no such thing as a negative time because those are scalar quantities. Everything else here is a vector quantity. So we are looking for the force of a 1,500 kilogram bus. It was driving down the highway negative 32 meters per second. And after 8 seconds, it had slowed down to negative 28. So that means it started off at negative 32. So its initial velocity was negative 32 meters per second. And then it slowed down to negative 28. So the final velocity is negative 28 meters per second. Okay, we have to solve for the acceleration. This, we have a v, v0, a. Oh, okay. We don't need the d. We don't need the displacement, the distance. It's just not relevant in this problem, which means the equation that we're going to use is v equals v0 plus at. I'm going to solve for the acceleration. We're going to solve for that acceleration. Negative 28 equals negative 32 plus A, 8. I'm going to add 32 to both sides. So this is going to equal positive 4 equals 8A divided by 8 divided by 8. 1/2 or 0.5 is the acceleration. And once I know that the acceleration is 0.5 meters per second squared, I can simply just use FEMA, F equals MA, F equals 1,500 times 0.5. F equals 750 newtons. That's it. Now, I know what some people are asking. They're like, how can I use that one kinematic equation, d equals v naught t plus 1/2 at squared? How can I use that equation to solve for the acceleration? The algebra there looks challenging. Rather than just do a full FMAVoVDAT, I want to do this one question that goes specifically to how to use the d equals v naught t plus 1/2 at squared equation. And the reason I want to go ahead and do this is because the algebra sometimes messes people up. So this is my distance. So I'm going to plug this in here. 60 equals, what is the acceleration of a ball that was moving? So this is, and was moving indicates a starting or an initial velocity. 3 seconds is, of course, the time. Plus 1/2, A is what we're looking for. And then the time is squared. This is what you have to do. 60 equals 5 times 3 is 15. Whoops, that should be a plus. 1/2 A, 3 squared is 9. Now I could take half of 9. So this is going to become 60 equals 15 plus 4.5A. Because multiplication is commutative, I can take half of 9. But the variable is still there. I'm going to then subtract 15 from both sides. 45 equals 4.5a. And then I'm just going to write it because I'm out of space. 45 equals 4.5a. I just rewrote it because I ran out of space. And I'm going to divide both sides by 4.5, the coefficient of the variable. And I get 10 meters per second squared is the acceleration. So sometimes the math on that equation will mess you up, but don't let it. Remember order of operations, and remember that multiplication is commutative. If you remember how to do the kinematic equations, we're just adding a step of FEMA, and ultimately that's not too bad. These problems are a bunch of work, but there's nothing you can't do. And FMAVoVDAT will guide your thinking.